position to become 0. Therefore, we start by looking at the position function. R of t is Vx cos theta ti plus V0 sin theta t minus 1/2 gt squared j. This is the x position of the projectile. This is the y position of the projectile. Now, during the time of flight is the time taken for the y position to become 0. And so, what do? We take the y position, set it equal to 0 and solve for the time. So y equal to V0 sin theta t minus 1/2 gt squared. Can you solve for t from here by setting y equal to 0? So 0 equal to V0 sin theta t minus 1/2 gt squared, and I solved it for you. Well, factor out a t. That means one value of t will be 0. Why? That is the time when the projectile begins. And the other time will be the time of flight, which will be 2V0 sin theta divided by g. Now this is an important equation. This is called the time of flight equation. The time of flight of a projectile is t equal to 2V0 sin theta divided by g. Let's now obtain an equation for the horizontal range. Well, this is the time of flight, t equal to 2V0 sin theta divided by g. And we had discussed this earlier. Horizontal range is the horizontal distance covered by the projectile during this time. And the horizontal distance x equal to the horizontal velocity multiplied by the time, isn't it? Okay. So horizontal range is the x displacement during this time. Therefore, range is Vx0 multiplied by the time of flight. What is Vx0? Well, Vx0 or Vx, since Vx does not change, it doesn't really matter. And what is that equal to? That will be V0 cos theta. So this Vx0 is V0 cos theta, and the time of flight is 2V0 sin theta over g. Alright, simplify this. That will be V0 times V0 is V0 squared. So that will be 2V0 squared cos theta sin theta over g. Alright, let me ask you this. I don't think many of you will recall. What does 2 sin theta cos theta represent? Can you remember an identity that you probably learned in trigonometry? You have most certainly learned that in trigonometry. What is 2 sin theta cos theta equal to? Well, 2 sin theta cos theta equal to sine of 2 theta. Sine of 2 theta. So we can now replace this 2 sin theta cos theta by sine of 2 theta, and so the equation for the horizontal range of a projectile is range equal to V0 squared sine of 2 theta over g. Now, the question I want you to answer is, if this is the range, what angle of projection will give you the maximum range? Suppose you cannot increase the velocity of projection anymore. Suppose you want to give some tip to Tiger Woods in his golf, and he cannot increase on its technique or the amount of force he can apply. Means he cannot increase V0 any further. Now tell him what angle he must hit to get the maximum range on a par 5. Now here I have an animation of 3 angles of projection. Now the first one is 30 degrees, the next one is 45 degrees, and the last one is 60 degrees. Which of them gives you the maximum range? That's very obvious there, is that right? Well, obviously you can see 45 degrees gives you a better range. Now why is it so? Let's look at the equation. The range x equal to v0 squared sine of 2 theta divided by g. Now the range becomes maximum when sine of 2 theta over g is the maximum. Now what is the maximum value of a sine function? You see, a sine function cannot exceed 1. Sine of 0 is 0, sine of 90 is 1, sine of 90 degrees, I'm not talking radians, sine of 90 degrees is 1, sine of 180 degrees is 0, is that right? So this quantity will become maximum when sine of 2 theta becomes 1, because sine of a quantity cannot be greater than 1. And when will this sine of 2 theta become 1? When this angle 2 theta is 90 degrees. So this happens when sine of 2 theta equal to 1 or 2 theta equal to pi by 2, which is 90 degrees. And therefore theta for maximum range is pi by 4, which is 45 degrees. Right? You got to fire a projectile at an angle of 45 degrees in order to produce the maximum range. I want you to look at this diagram, and I haven't given you any assignment for extra credit so far. Now this is an extra credit assignment. Now look at this. An angle of projection 75 degrees and an angle of projection 15 degrees give you the same horizontal range. An angle of projection 60 degrees and an angle of projection 30 degrees gives you the same horizontal range. And the maximum range occurs for 45 degrees. Now, the assignment is this, and I will give you 2 extra credit points for that. Alright, if you don't want it, you don't have to send it to me. But if you want it, write a good paragraph showing solid reasons why these 2 angles, 75 degrees and 50 degrees, gives you the same horizontal range, why 60 degrees and 30 degrees gives you the same horizontal range. Alright, show me the arguments using mathematical equations if you like. Alright, and that carries 2 extra credit points. Okay, now I want to ask you a question. Now the question is this. It's an old question actually. Here is a hunter. A hunter is hunting a monkey. This is the unfortunate monkey. Now this is a tree branch. The monkey is hanging from that branch. Now the hunter wants to shoot the monkey. Now the question as physics students going to advise the hunter, do you really have to, what direction should the hunter really needs to shoot? Because this monkey is a very clever monkey. You know what the monkey is going to do? As soon as the hunter pulls the trigger, you know, he can see the fire. He's going to let go. That means he's going to drop. You see, the monkey says, I will teach you a lesson, hunter. So the moment the hunter pulls the trigger, the monkey lets go from the branch and falls. Now, The hunter knows that, because the hunter, this is not his first time. The hunter knows that the monkey is going to drop. So in what direction should he aim the rifle? Now, at the moment it is aimed directly at the monkey. Now, will the bullet hit the monkey? What do you think? At the moment the gun is aimed directly at the monkey. And the moment the bullet is fired, the monkey is going to let go from the branch. Will the bullet hit the monkey? Or will the hunter lose a bullet and lose the monkey? I'm sorry, I'm hurting some of the feelings that the hunter is hunting a monkey. Well, it's just figurative. Okay? Well, let me animate this and see where is the bullet going to go. Alright, watch it and explain this to me. Well, what happened? Watch it again. Did the bullet hit the monkey? The poor monkey would have been fortunate to stay there. Because the monkey dropped at the same time the bullet is fired, it got hit. Why? Because the moment the bullet comes out of the gun, it begins to fall freely. And the monkey decides to fall freely as well. That means the bullet and the monkey are falling at the same rate. So the bullet doesn't go straight at the monkey. The moment the bullet comes out, it falls like this. And the monkey also falls, and the bullet goes and catches the monkey. You see, that is the situation. Okay, let me also show quickly a couple of other animations that I have taken from open webs. The same